Good day, folks. This is the first video in a series on statistical reasoning. The series is based on academic readings that has been published in the field of statistical reasoning. And yeah, let's start. What's the current state of teaching of statistics in schools? Well, let's look at the problems that's been identified in teaching and learning of statistics. And the first big problem is that it's a new and emerging discipline. Statistics has formerly been included from the year 2000 in America, and currently later in South Africa it made its way into our curriculum. Leading statistics educators urge a reform of statistics instruction and a curriculum based on strong synergies among content, pedagogy and technology. Now folks, that should, if we look at that last sentence, a curriculum based on strong synergies among content, pedagogy and technology, that says a lot about the state of statistics teachings in schools, if that is not what is happening through the curriculum. There's a list of identified problems in teaching of statistics, the first of which is an exclusive focus on mathematical and mechanical aspects of knowledge, which results in students not being able to apply their statistical ideas and statistical knowledge that they've gained. And they cannot work. But as a result of that, they cannot work in contexts, in contextualized situations, and make generalizations on statistical observations that they made, because the focus is purely on the mechanical aspects of their knowledge. Maths phobia plays a huge role. Statistical anxiety, and broadly a lack of interest from learners to learn statistics. And I mean, it's those two things that generates this lack of interest. People run away from statistics. Statistical anxiety, you go to a university, you hear, oh my goodness, the failure rate in Stats 1 is huge. And people do not decide to take the statistics course at a tertiary level because of that anxiety. The ideas of probability and statistics are also very difficult for learners, for teachers and for students in a tertiary institutions to learn. Probability was not part of the teacher training curriculum years ago at universities, and the curriculum changed in South Africa, and we have to teach probability for paper 1, and then the second paper for mathematics in our country deals with statistical reasoning. Now, these things were not taught to teachers when they qualified at their undergraduate degrees. There's also deficiencies in basic statistical knowledge and the appropriate application of statistical knowledge and statistical methods. There's a serious lack in basic knowledge about statistics. Statistics courses are given as in-service training to teachers with no link to subject area. In our country, we've seen that to keep your SACE registration as a teacher, you have to continuously train and keep your skill set up to date. So yearly you earn points for attending workshops, and I've done some of these workshops for teachers, and when I ask the teachers, what do you need help with, it's almost a choir that says probability. So people find statistics courses, find probability and statistics courses that deals with probability difficult, because it's literally a few hours in the course, or 2 or 3 days, the course is over, and then you're back in the class teaching the content that you learned in the course. There's also a deficiency in tools to assess statistical thinking and literacy of population in the social settings. These tools to assess statistical thinking is a wide range or variety of tools. If you open a matric paper, for instance, now, you'll just see there's a set of data points given, and learners are asked to do A, B, C, and D. And maybe point E is a question where they have to absolutely use their statistical knowledge and reasoning to talk about what they have just done. Okay, so there's also a shortage of statistical staff at universities in particular. Statistics is declining as a taught subject, folks, and that is hugely problematic, particularly when we're talking about training teachers, initial teacher education. The statistics courses that we find sometimes at universities is just a rehash of what is learned in grade 10, 11 and 12 at school level, without the necessary extension to extend the teachers in training beyond the level at which they are going to function with their learners at school. And then the last the identified problem in teaching statistics is a big one. The shortage of statisticians in the workplace is huge. Okay, and that is now we're talking outside of the, not only outside of the realm of the classroom and in teaching. We're talking in general here as well, that there's no qualified, seriously hard statisticians in the workplace. So that's a problem. Well, how do we develop statistical literacy? We can ask ourselves. There's a movement to socially based curriculum frameworks and towards application-based approaches to teaching students to think critically about social situations in which data is used, sometimes referred to applying statistical literacy. Okay, so there's a movement that's advocating for this. GAL 2000 proposed a statistical literacy model which comprises of two broad interrelated components. A knowledge component is the one, and a dispositional component is the second one. The knowledge component consists of 5 cognitive elements, and the dispositional component consists of 3 related but distinct concepts. Now, I strongly suggest, folks, that you look for that paper of GAL online and that you make it your business to read it. It's very, very interesting reading. It's not included in our course here, but it makes for very interesting reading. Watson, as early as 1997, suggested that the skills required to interpret stochastic information presented in society can be represented in a 3-tiered hierarchy with increasing sophistication. Firstly, a basic understanding of probabilistic and statistical terminology. That's your first tier. Secondly, an understanding of statistical language and concepts when they are embedded in a context of wider social discussion. And lastly, a questioning attitude to contradict claims, to question claims made without proper statistical foundations. Now, those are 3 things that we will see in our second part of statistical reasoning that Cobb and McLean take up in their seminal paper related to statistical teaching and learning at a school level. Or at I think their research happened at primary level, possibly foundational or middle school level. Okay, so understanding of statistical language is the job of the teacher. And we saw in the previous slide that teachers have a problem understanding statistics and probability themselves. It is a very uncertain area of mathematics, and it's hard to deal with. It's not as clean-cut as what mathematics is. You solve an equation, you know what that solution represents. You don't have to interpret it because that solution belongs to a function maybe. Roots you found of a function, or turning points on a graph, or whatever it was representing, a maximum area. Your answers are certain. Statistics, there's a grey area, and that is what makes it very difficult. So, to foster that basic understanding of statistics, to work on statistical language and discourse in the class, ways to talk about statistics, and also to develop a critical eye with our learners at a very young age, develops the notion of statistical literacy. So what are the strategies for reform-based teaching of statistics? Let's see what's suggested. Well, there's a change in content of statistical courses, especially introductory level courses. Now, folks, we can go to the South African curriculum and we can go through it and we can see how many years do students work out the mean, the median, and the mode of a set of data. And that information makes it onto a matric paper in a very mechanical way. At best, they're asked to describe the distribution, and then they rely on their mechanical methods. Well, let's see if the mean is bigger than the median. Then we know, teacher told us, it's either left skewed, right skewed, whatever the case might be. Okay, so they're advocating for really a content of statistic courses to change, and change dramatically. We'll see in Cobb's, in part 2, how Cobb and them suggest what happens. Well, improving the instructional techniques used in statistical courses. You go into a class, you classically will find out, well, today we're going to learn about the median. Check if there's an even number of data points. If not, do this. If there is an even number, there are an even number of data points, then do this. So, do we talk about it? Do we interpret what we've just worked with? Or does it become a heading with a mechanical procedure connected to it? Also, point C, reforms in terms of pedagogical changes. The way we teach the subject has to change. And again, I'm saying part 2 is a very exciting part of the statistical reasoning series that I'm making for you folks. Please make sure as well that you read the paper of Cobb and McLean. There's a lot of suggestions there that make sense in how this reform statistical movement can find its roots into the mathematics classrooms at school. Lastly, and this is what a huge problem in our country, is the use of technology and using computer simulation methods when we teach statistics. First of all, because of access. Not all schools have access to technology. Not all schools, even in South Africa, have access to electricity. So it's problematic. It's really problematic. It's now, what, 22, 23 years of our democracy, and we are still in schools where we don't have electricity, where schools don't have things that they call math labs, where there's an electronic smartboard, there's Wi-Fi or fiber available at the schools. So it's a serious problem in third world countries that technology is not available to everyone, and it has access problems. So research suggests that putting cognitive theory into practice will be advantageous for statistics education. Now remember, cognitive theory is stimulus and response, broadly put. There's more to it than that. Many researchers agree that using the problem-solving approach in the teaching of statistics is of great benefit to both teachers and learners. Now folks, by problem solving, we all are aware, we don't mean do exercise 5.2 in your textbook and solve that problem. Problem solving means we have a problem that we look at as a classroom community. Okay? We talk about it, we investigate it together, and we learn from that process. We learn how to develop our statistical reasoning, statistical thinking, and statistical literacy ability. So an overview of the reform-based learning strategies and techniques is what we will look at next. Integrating schemes for assessment of statistical thinking and statistical literacy in the curriculum. Okay, that is one technique that can help us improve the statistical literacy levels at school, not only with kids, but with personnel, with teachers, at universities, with students that are at the tertiary institution. Shifting the focus of statistics curricula from mathematical calculations, the ones I just spoke about, to tasks of a practical nature. There's a problem. Let's look at the problem. Let's look at what the data says and do our investigation. And in that process, learners' statistical thinking and their statistical literacy is supported and developed. Developing also your problem-solving skills. Problem-solving skills in a statistics class is different from what is needed in a mathematical algebra class or a calculus class. Things happen differently. Again, I'm saying statistics and statistical reasoning. That is the name of the subject as it appears in the curriculum. It's statistical reasoning. Reasoning about data. What do I read in this data? What can I conclude from this data? How do I prove it? Which mathematical tools is applicable for me to be proving something that I'm claiming? Fourth point, developing statistical literacy and critical thinking skills. Now folks, this happens when you apply collaborative learning in class. Kids work on a problem together in groups. There's a carefully designed task by the teacher, and it's their task to solve the problem, with the teacher monitoring and evaluating progress, and obviously working on language and reasoning while this is happening in class. Active learning and introducing activities where students are able to construct knowledge, not to perform a few procedures and get a correct answer for a median, for a mode, for a mean, for a standard deviation. I can carry on forever. Okay, so collaborative learning, problem solving, and activities that construct knowledge. Teachers need to target, you know about the misconceptions that kids have in certain areas of statistics. Target those misconceptions through discussion and assessment. I would say both. First the discussion and then later on assessment. That assessment can happen after the discussion. It doesn't have to be a test. We'll have to revisit. We've seen the misconception appear. We discuss it in class. Then we go back and we revisit and see what we would now do differently or say differently about the object that we are working with. Okay, and then hugely developing the skill of communicating statistics. It's a huge problem all over. How do children, students, teachers talk about the maths that they're using? How do they communicate the mathematics? And in statistics, because it is contextual, it is embedded in context, those communication skills and the language that kids need to talk about what they're working with has to be developed continuously by the teacher. The use of technology again and online resources. Folks, again, in the schools where this is possible, and there are a lot of schools with what they call mathematical labs, where government have put in smart boards or electronic boards that are connected to the internet. Use the online resources. If the child asks you as a teacher, "Sir, why is the median and the mean so different? What is the difference between the two?" Okay, demonstrate that. Go to an online resource and type in the difference between a median and a mean visually. And use the online resources. I often do that when I teach. So online resources, particularly in the statistical class, can help the teacher make sense for the learners about what it is that you want them to see. Okay, folks, I think that's enough for part 1. I hope you learned something from part 1 and that it made you think, at least made you think, and interested in what's coming next. So if you like this video, please just press the like button, subscribe to the channel, and then also share the video with somebody that you might think would like it.